Tom Brady told you to trust FTX. Ford, GM, and Ram told you to trust turbo engines. Both of those pitches had the same structure. Take something people already like, wrap it in better marketing, strip out the proven technology underneath, and hope nobody checks the math until the warranty expires. Ford called it EcoBoost. GM slapped a turbo four-cylinder into a full-size Silverado. Ram wired a 48-volt battery to a Hemi and called it eTorque. Every single press release said the same thing. More power, better fuel economy, the future of trucks. And for a while, most buyers believed it. The Ford F-150 with the 3.5-liter EcoBoost became the best-selling truck configuration in the country. GM pushed their 2.7-liter turbo as the base engine in both the Silverado and Sierra. Ram made eTorque standard across most of their 1500 lineup, but now those trucks are hitting 40,000, 60,000, 80,000 miles, and the service departments are telling a very different story than the brochures did. Let's start with what actually matters to your wallet: fuel economy. The entire pitch for downsized turbo engines was that you could get V8 power from a smaller, more efficient package. Ford's 3.5-liter EcoBoost V6 carries EPA ratings of about 18 miles per gallon in the city and 24 on the highway. The 5.0-liter Coyote V8 in the same F-150 gets 17 city and 23 highway. That is a difference of 1 mile per gallon. 1 mile per gallon. That was the revolution. And those are the laboratory numbers. Real-world driving closes even that tiny gap. Owners on truck forums who have driven both engines back-to-back report that highway fuel economy is essentially identical between the EcoBoost and the Coyote V8. One longtime Ford owner who ran a 2019 EcoBoost and then switched to a 5.0 said the V8 actually averaged higher highway numbers, consistently hitting 21 miles per gallon, where his turbocharged V6 never cracked 20. The reason is simple. A turbo engine only saves fuel when the turbos are not working hard. The moment you accelerate, merge onto the highway, tow a trailer, or drive through hill country, those turbos spool up and the engine is burning fuel at a rate comparable to or worse than the V8 it replaced. You are paying for efficiency that only exists when the truck is doing nothing demanding, which is not how most people use a truck. GM's situation is even worse. Their 2.7-liter turbo four-cylinder was positioned as the efficient base engine for the Silverado 1500. On paper, it made sense. Impressive torque numbers, decent horsepower, and fuel economy that should have embarrassed the old 5.3-liter V8. In practice, Colorado and Silverado owners started noticing the opposite. Multiple owners in GM truck forums have pointed out that the 2.7 turbo actually returns worse fuel economy than the naturally aspirated 3.6-liter V6, and in some configurations, worse than the 5.3 V8. One forum poster put it bluntly, the 2.7 is more complicated than the 3.6. Turbos are usually more problematic than naturally aspirated engines, and the mileage is worse, not the same, but worse. So the fuel economy promise is, at best, marginal. At worst, it's a lie when you factor in how people actually drive trucks. Now let's talk about what breaks. Ford's EcoBoost engines use direct fuel injection, which means fuel spray straight into the combustion chamber instead of washing over the intake valves first. That design choice creates more power and better combustion efficiency. It also means nothing is cleaning the backsides of your intake valves while you drive. Over tens of thousands of miles, carbon deposits build up on those valves. The engine starts losing power. It idles rough. The check engine light comes on, and the fix is a process called walnut blasting, where a technician literally shoots crushed walnut shells at your intake valves to scrape the carbon off. That service runs $400 to $600 at most shops, and on first-generation EcoBoost engines, it needs to happen every 40,000 to 50,000 miles. Ford themselves cautioned against standard intake valve cleaning methods because the chemicals can damage the turbocharger's turbines, bearings, and seals. But carbon buildup is the cheap problem. The expensive one is the timing chain. Ford's 3.5-liter EcoBoost timing chains stretch under the stress of turbocharged operation, especially when oil changes are delayed even slightly. When the chain stretches, the engine falls out of timing alignment. The symptoms start as a rattle on cold startup and escalate to misfires, power loss, and eventually a check engine light that will not clear. Replacing the timing chain, tensioners, and guides on an EcoBoost requires significant engine teardown. Dealerships routinely quote $2,000 to $5,500 for this repair. Independent shops can sometimes do it for less, but you are still looking at a multi-thousand-dollar bill on a truck that was supposed to save you money at the pump. Ford did address the carbon buildup issue in second-generation EcoBoost engines by adding supplemental port fuel injection alongside the direct injection system. That helps clean the intake valves. But the timing chain concerns remain across all generations, and turbo replacement, when it eventually comes, runs $1,000 to $3,000 depending on the setup. GM's 2.7-liter turbo has its own collection of problems. The active fuel management system, which deactivates cylinders to save fuel, has been a persistent source of complaints. Owners report lifters that wear out prematurely, excessive oil consumption, sudden stalling, and hesitation during acceleration. Fixing active fuel management-related failures typically costs $1,000 to $2,000. Then there are the injectors. GM identified that some 2019 through 2022 Silverado 1500 trucks with the 2.7-liter turbo had improperly programmed engine control modules that caused the injectors to deliver the wrong amount of fuel. That triggered misfires, rough idling, and reduced performance across thousands of trucks. And the most alarming issue, cracked engine blocks. GM issued a recall covering certain 2023 Chevrolet Silverado 1500 and Colorado models equipped with the 2.7-liter turbo after discovering fractured engine blocks coming off the production line. The company offered full engine replacements at no cost, but the recall itself tells you something about how hard this engine is being pushed. One Silverado owner on a GM forum shared that at 82,000 miles, his camshafts failed completely. He called the engine's valvetrain simply not up to GM's reputation for small block V8 reliability and durability. Another owner reported that his dealer quoted $10,000 to $12,000 to repair a top-end failure on his 2.7 turbo at 66,000 miles, just 6,000 miles outside his drivetrain warranty. He ended up buying a used replacement engine for $3,500 and installing it himself to save money. Compare that to the naturally aspirated 5.3-liter V8 that has been in GM trucks for over 2 decades. Owners routinely report 200,000, 250,000, even 300,000 miles with nothing more than standard oil changes and basic maintenance. The 2.7 turbo does not have that track record. It may never develop one. Ram went a different direction with eTorque, but the destination was the same. Problems. The eTorque system bolts a 48-volt battery and a belt-driven motor generator unit to the existing Hemi V8 or Pentastar V6. It is supposed to capture energy during braking, smooth out the auto start-stop system, and provide a small boost during acceleration. On paper, it is clever engineering. In garages and on the shoulders of highways, it has been a reliability nightmare. Ram recalled 131,702,021 Ram 1500 trucks equipped with 5.7-liter eTorque engines after discovering that a software defect in the powertrain control module could cause the engine to suddenly shut off while driving. The recall documentation noted that Ram had received over 900 reports of stalling, including one crash. The problem was an incorrect air-fuel mixture triggered by faulty software that could flood the engine and kill it without warning. This stalled issue was severe. Beyond the recall, eTorque owners have reported a litany of cascading electrical failures. The 48-volt battery drains faster than it charges, especially in cold weather. When that battery dies, the eTorque system goes dark. And because Ram integrated the system into vehicle electronics, a dead eTorque battery does not just kill the mild hybrid assist. Owners have reported losing power steering, brake assist, automatic emergency braking, blind spot detection, and their infotainment systems, all from one failed component in a system that was supposed to save them a few miles per gallon. The eTorque motor generator unit replaces the traditional alternator. When it fails, there is no standard off-the-shelf alternator to bolt in its place. You are buying a specialized component from the dealership, and owners have reported back orders stretching 30 to 45 days or more. A brand new Ram 1500 sitting in a service bay for over a month, waiting for a part that a traditional V8 truck would never need. If you are keeping score, here is what the turbo and mild hybrid revolution has actually delivered. 1 to 2 miles per gallon of theoretical fuel savings that largely evaporate in real-world driving. Carbon buildup requiring $400 to $600 cleanings every 40,000 to 50,000 miles. Timing chain replacements running $2,000 to $5,500. Turbo replacements at $1,000 to $3,000. AFM system failures at $1,000 to $2,000. Engine block recalls, camshaft failures, cascading electrical shutdowns, and repair quotes that can reach $10,000 to $12,000 on trucks that are barely out of warranty. That math does not work, and the used truck market is starting to figure it out. Resale values on turbo-equipped trucks are softening relative to their V8 counterparts. The reason is straightforward. A used truck buyer looking at 2 F-150s on the same lot, one with a 5.0 Coyote V8 and one with a 3.5 EcoBoost at similar prices, is increasingly choosing the V8. Fewer turbos to replace, fewer intercooler issues to diagnose, fewer carbon cleaning appointments to schedule. The naturally aspirated engine is a known quantity with a 15-year track record of durability. The turbo engine is a bet, and many buyers do not want to gamble with a $50,000 truck. So what are smart buyers actually doing right now? They are hunting Ford F-150s with the 5.0-liter Coyote V8, especially 2018 and newer models paired with the 10-speed automatic transmission. That combination gives you 400 horsepower, 410 pound-feet of torque, real-world fuel economy within a mile or two per gallon of the EcoBoost, and a naturally aspirated engine that many owners are driving past 250,000 miles without major powertrain work. On the GM side, they are looking for pre-turbo Silverados and Sierras equipped with the 5.3-liter V8. That engine family has been in production for over 20 years, and the aftermarket support, parts availability, and repair knowledge base is massive. When something eventually does wear out at high mileage, the fix is usually straightforward and affordable compared to turbo engine repairs. Some buyers are also looking at the Toyota Tundra with the 5.7-liter V8, the model produced through 2021 before Toyota switched to their own twin-turbo V6. That naturally aspirated Toyota V8 has a reputation for lasting well past 300,000 miles with minimal intervention. And here is the part that should make you pay attention. This window is closing. Manufacturers are phasing out naturally aspirated V8 truck engines. Ford still offers the 5.0 Coyote, but industry analysts expect it to disappear within the next few model years as emission regulations tighten. GM has already pushed the 2.7 turbo deeper into their truck lineup. Ram is transitioning to the Hurricane inline-6 turbo engine as their new standard. The era of the simple, proven, naturally aspirated V8 truck engine is ending. That means the used trucks equipped with those engines are going to become more desirable, not less. The supply is fixed. Every V8 truck that gets wrecked, traded in, or sent to auction is one fewer available to the next buyer. If you are shopping for a truck right now and you plan to keep it past the warranty period, the math points in one direction. Find a clean, well-maintained, naturally aspirated V8 truck while they are still on dealer lots and private seller listings. Because the industry bet on turbos and mild hybrids, and the service departments are cashing those checks right now. If you found this breakdown useful, subscribe. I cover the real numbers behind automotive industry decisions every week, not the press release version. And if you want to see which specific model years and configurations to target and which ones to avoid entirely, that video is on screen now.